Okay, good. So now it turns out that PageRank can be done really nicely with MapReduce. And that has to do with the fact that PageRank is a staged algorithm, right? So at each stage, at each iteration, you take a set of numbers and you do some computation with them and you end up with another set of numbers, right? And then all you need is that last set of numbers and then you have the next stage and the next stage and the next stage. So you can implement it pretty nicely with MapReduce. And the way you do this is you set up your mappers and reducers sort of as follows. So your mapper is going to get one row of the adjacency matrix. So, and that row basically, Y is the row number, right? That's the node in a graph. And it's going to get a set of outgoing links from that node. So the mapper is going to emit the initial PageRank. So what does it do? It goes for each node that it connects to. So Y points to a bunch of nodes. For each node that it points to, I'm going to take my current PageRank, the current PageRank of Y at this point. What is it? It's just 1 over the big N, right? The number of nodes in the graph. So that's my PageRank. My out degree is little n. That's how many neighbors I point to. So for each one of those neighbors, xj, I take my PageRank and I divide it up equally, right? So that's my PageRank, I divide it by the number of neighbors, and I emit that little contribution to each one of my neighbors. So you need xj and the delta, right? So a little portion of your initial PageRank goes to all of your neighbors. Okay. Now what the reducer is going to get, this xj is the key in the tuple that you're emitting. So the shuffling step in MapReduce is going to aggregate all of those contributions for a single node xj, right? So it's going to take a single node and it's going to put together all of the contributions from the nodes that point to xj, right? So these are the nodes y, y1 through ym. Each one of them contributes one of those numbers, right? And what the reducer is going to do first is it's going to compute the PageRank for node x, just using the equation that we had on the previous slide. So you walk over this array and add up those numbers, multiply by lambda, and interpolate with 1 minus lambda over n, right? That's going to be the current PageRank of node x, right? And then what you need to do is you've computed the PageRank for x, so now you need to continue the computation. And the way to continue the computation is take this PageRank and send it out to all the nodes that you point to, because that's your new PageRank, and now share it among the outgoing links, the neighbors that you point to. Okay, great. So it's not, it's the kind of a MapReduce job where you will have multiple reducers. You have a single mapper to initialize numbers, and then each iteration, you're just passing the results from the previous stage to the new stage. So you will have multiple reducer stages in this kind of a flow. And I guess if you look at this carefully, you'll notice that there's a little bit of a bug in this algorithm. And the bug comes from the fact that here I'm emitting these PageRanks to my outgoing links, right? And the problem is, as a reducer, you don't actually know what your outgoing links are, right? So here's a trick question. Why can't you just look it up? Why don't you have why can't you just look it up at this point? Why can't a node look up what its outgoing links are? Well, to do that lookup, your reducer would have to have access to a data structure that represents the entire graph, right? You have to get a row out of that adjacency matrix. And the whole reason you're doing MapReduce, right? You wouldn't be doing MapReduce if your graph fit on a single machine. The reason you do MapReduce is you want to do PageRank on the web. The web graph doesn't fit on a single machine, even if you store it on disk. So you can't look it up. The point is, different portions of the data sit on different machines. So there isn't a central data structure which has the entire graph where you can look up, well, what are my nodes, right? But you can actually fix it really easily if you have the mapper emit the outgoing links as well as the page ranks, then what's going to happen is the reducer, when it gets the contributions from the in nodes, it's also going to get a list of its out nodes as a special element of the list. And it's going to be a different element, right? All of these are numbers, and this is going to be a list, so you can identify it pretty easily, right? And now you have this list, and you can just emit the same list for the future reducers to use, right? So this way, you implement the entire thing in MapReduce, and you don't need to store the web in a single data structure. It lives distributively, so nice and beautiful. Okay. So that's PageRank in MapReduce. Now, there is a bit of a problem with it. Okay, yeah. How does it participate in the hashing? So this is the key, and this is the value, and this is the key as well, right? So I'm emitting a bunch of keys. These keys have the out nodes, right? And this key is Y itself. So,
but then it doesn't go to the C reducer.
Of course it doesn't. It goes to a different thing, and that's what you actually want, because one of the reducers will get a Y, right? So one of the reducers, the X will be Y, and that reducer will get the list of outlinks that it needs. Okay. I don't want to spend too much time here. We have a lot more to cover. Go through this. Make sure you understand it. It is correct.